Okay. Okay, I've started the recording now. All right. So before we start building the solution, so just to discuss why we use SSAS is mainly because due to our reporting requirements, so we use analysis services because it provides a more robust and intuitive platform based on which you can analyze your data, you can slice and dice your data, and you can play with your data and do different kinds of analysis. So even there are many projects where you might see that there are reports which are directly built out of the relational data warehouse. So once the data is loaded in the relational data warehouse in the fact and dimension tables. So reports are created directly from the fact and dimension tables without using analysis services. So it all depends upon the reporting requirements. So if you have a static kind of reporting requirement where you have some fixed questions, and the reports will provide you the answer to those questions only. Like for example, you have some fixed queries that and those reports will provide you the details about those queries. Now let's say if you want to analyze the data rather than you have a more dynamic requirement whereby you want to analyze the data and then come to a conclusion. So you want to slice and dice the data. Based on that, you can come to a conclusion. So let's say what I'm saying is you have a kind of a reporting requirement where let's say you are looking at um, sales amount. Sales amount is a metric, and you're looking at sales amount for a particular geography in a particular year. And so you have that information. That was your first question. So you get the answer for that, and then from there you want to get into, you want to see the answer to your second question, that who were the customers for which the sales amount, you have that much of sales amount. So the customers are the second question. Then once you get the customers, then maybe you have a third question, that what is the financial background of those customers. So you are kind of doing an analysis, you're slicing and dicing the data, and your reporting requirements are not static. You're analyzing the data and then you're coming at a conclusion. So that kind of reporting requirements if you have, then probably that is where the analysis services comes into the picture, and it plays a major role. And also with respect to performance is also a critical factor due to which people use analysis services, because when you are slicing and dicing the data, you cannot wait for a long time, right? But when you're doing the analysis, let's say you're looking for one answer and you have to wait for 5 minutes to get that answer, then you will go for the second stage of your analysis. So that is not acceptable in today's BI world. what people want is they want the answers within a few seconds, and then they will do the second phase of analysis, ask the second question, get the answer within a few seconds, then ask the third question. So like that. So usually with analysis services, the benchmark is, you can say, maximum 20 seconds. So when you're asking a question or when you're analyzing the data, you should get the result within 20 seconds. So that kind of performance is a little bit difficult to achieve directly from the relational data warehouse. So relational data warehouse, you can build reports out of it, but those are mainly static kind of reports where you have fixed queries, and also the performance may be even if it is taking 5 minutes for you to deliver the reports, it is fine. So it's not an issue with the user. So, so that is where analysis services fits into the MSBI architecture. Okay, so what I will, when you talk about SQL Server 2012, so with analysis services, there are two flavors of SSAS. I would say that Microsoft has launched with SQL Server 2012. You have Multidimensional SSAS and you have Tabular SSAS. So most of the features, I would say 90 to 95% of the features are present in both. So I'll start with multidimensional SSAS and build a solution based on multidimensional SSAS, and I will be using the AdventureWorks DW 2012 as my source, as my relational data warehouse. So I think you already have this database installed, right? The AdventureWorks DW 2012.
Yes, they have. Yes, they have.
Okay. All right. So let me start building a solution. So I'll create a new project. So here you can see that if you want to create a multi-dimensional solution, you'll select this. If you want to create a tabular solution, you'll create this. And this is like these two options are if you want to import a solution from a database. So if you want to import a multidimensional solution from an existing analysis services database, you can use this option. And if you want to import a solution from an existing tabular database, so you can use this option. So I'll create a multidimensional solution, and this is the location, and I can give any name to the project and to the solution. So let me, okay. So the project and the solution is created. So the first thing that I need to set up is my data source. So data source is the database from which the multidimensional cube or the dimensions will source the data. So in my case, the data source would be AdventureWorks DW 2012. So I'll right click and click on new data source. So here actually I had created one data source earlier, so I'll create a new one. So actually I have installed my database engine on an instance dev01. So here I have this database AdventureWorks DW 2012. I click on OK. Click on next. Now on this screen you can see the different options here. User specific Windows username and password, user service account. So this is the account using which SSAS would log into the AdventureWorks DW 2012. Okay, so if you use a specific Windows username and password, that Windows account needs to have access to your AdventureWorks DW 2012. If you use user service account, it means that you need to give access to the SSA service account to your AdventureWorks DW 2012. So I'll go with user service account. Click on next. I can give any name to it. So I'll go with AdventureWorks DW 2012 only. And I click on finish. Okay. Now the next thing that we need to set up is the data source view. So data source view is kind of an interface on top of your data source based on which your cubes and your dimensions are created. So it is kind of an intermediate layer where you can do a lot of calculations, intermediate calculations. You can use named queries, you can put named calculations, and you can modify the queries and the tables based on your requirements and then bring it onto your multidimensional cube and dimensions. So this is my data source. And here you can see these are the tables in my, on my data source, the tables and views. So I can select if I would just want to bring in 5 or 6 tables to my multidimensional cubes and dimensions. I can just select those tables. So as of now, I'll just select all of them and then click on next. So this is the data source view name. I click on finish. So you can see here that it has already picked up the existing relationships which are there in the in these tables. So the primary key, foreign key relationships between different tables that the data source view has picked up by itself from the tables. So here you can do a lot of customizations with the data. For example, let's say you have this dim date. Now here you can create a new named calculation and you can write an expression here, give a name and then create a named calculation and then use that in the group, in the cube or in the dimension. Also you can, this is coming directly from the table. So if you want to add a join or a where condition, you can replace the table with a new named query. And then you can write a query here, like you can put a join with another table or you can write a where clause, and you can model your data according to your need in the according to the way you want your data in the cubes and in the dimensions.
Indrashish, I have a question here.
Yeah, tell me.
Why did you use like your well in the design? Why did you use like did you use all the tables in there, or are you using like only specific tables in here?
No, while creating the data source view, I have selected all of them. But if I want to select some specific tables, I can do that.
Okay, but because here I'm asking you this question because I can see only just 1 or 2 tables on the screen, and we can't really see the what kind of relationship they have, and where are they getting connected to, and to what we are getting connected to.
Actually, let me fit the this everything you cannot. Let me zoom it a little bit, then probably you'll be able to see.
Okay.
So you can see now. Are you able to see it now?
Well, I can definitely see it, but still, like, we can't figure it out, like, who is related to what, and, like, you can't really make out anything. It makes no sense, you know what I mean?
So let's say...
Okay, here now. How about we take, like, a couple of tables and define it instead of taking, like, all of them together?
Yeah, that we can do. I can... let me just remove this and create a new one.
Can you just move the selected thing? Because in our earlier exercise, we didn't use all the tables. It will be very difficult for us to understand. We are just starting our SSAS classes.
Thank you, Indrashish.
So let's say I take the dim customer and then dim date. dim employee, dim product, dim product subcategory, dim reseller, dim sales reason, fact internet sales, fact reseller sales. Okay, so I just selected a few of the dimensions and a couple of fact tables. So you can see here that this fact reseller sales and so this is our fact table, and we have these dimensions which are linked to the fact table, like we have dim reseller, which is related to this through the reseller key. We have dim date, which is related to this fact table using the order date key, due date key, ship date key. This is the dim product, which is related to using the product key. If you want to see the relationship, you can see here. This is the fact table, this is the dimension table, and this is the source and destination columns. So you can see this is the relationship between fact reseller and dim reseller based on these columns. Okay. Now if you want to add or remove any table, it is easy. You can just right click on here. You can add, remove tables, and you'll get this get to this window, and you can add any table from here, or if you want to remove any table, you can remove it from here. So I've brought in another fact table here, which is the fact internet sales. So this table also has relationships with these dimensions. Ideally, the way this database is structured is there are two types of sales. One is sale through resellers, and one is sale through the internet. So fact internet sales is the fact table which contains all the records for the sales through internet, and fact reseller sales contains all the records for sales through resellers. Okay, so when you build the multidimensional solution, the first the first thing that we usually do is we build the dimensions first, and then we build the cube. Why? Because when we build the cube uses the dimensions which you have already built. So that is why there is a dependency on the dimensions which are built. So that is why we develop the dimensions first, and then we build the cube. So what I'll do is I'll first create one of the dimensions. Let's say I'll create the customer dimension here. This dim customer. So what I'll do, one thing is that when you're creating a dimension or when you're building create a measure group in a cube, so that the underlying query or the table based on which the dimension will be built or the measure group in the cube will be built, that has to be present in your data source view. So if it is not present in the data source view, you have to add it. Like you can right click and add remove tables from here. Okay, if you have additional tables there in your data source view which you are not using in your cubes or in your dimensions, then it is of no use. This data source view is just an underlying interface on top of which you will build your dimensions and the cubes. This data source view will not be visible to the end user. The end user cannot see the data source view. So I'll use an existing table, and this is the data source view, and you can select. So these are the tables which are there in the data source view. So I'll select dim customer, and customer key, the key column is nothing but the you can say the primary key of that dimension table, primary key or the surrogate key. Now the reason why it is showing this related table dim geography is because this the architecture of this dimension, it's a snowflake dimension, and it is related to the you can see here that in dim customer there is a geography key. So using the geography, in dim customer, I have the geography key, and through the geography key, it is related to another dimension, which is the dim geography. So what it is asking me is, do I want to bring in the columns of which are there in the in dim geography? Do I want to bring it into this dimension as well? So I'll give you an, let me show it here. I think it will be better if I show it here. So this is my dim customer table, and so I have just created, just added the related tables. So you can see here that this dim customer is related to dim geography via this geography key. So this is ideally this is the geography of the customer, and it is this key is present in this table, and the geography related information, the city, state, country, these are present in dim geography, and this customer key is present in the fact internet sales table, this customer key. Okay, so the dim customer is related to dim geography via this geography key. This is kind of what do you say, a snowflake architecture. So when you're when I'm building this dim customer dimension, since it is detecting that relationship between customer and geography, that is why it is asking me whether I want to bring in the attributes which are present in dim geography in this customer dimension as well.
Indra, I have a question here.
Yeah.
Hello.
Yes, yes.
Suppose you don't select these related tables at this stage when you create a dimension, and when there is a need to add it later, it will disturb the previously created cube anyway, or it will not have any impact.
See, let's say let's say in dim customer, it depends because depends on your development. In dim, like in this case, dim customer and dim geography, they are related using the geography key. Now you don't bring in dim geography. You only create a dimension out of dim customer. You can create that, and then in the cube you can set up the relationship between the fact table and that dimension table using the customer key. No issues. Now let's say you want to bring in dim geography. You can bring in dim geography in the cube. You have to say, now the question is whether the geography attributes that you're bringing, if you want to create a single dimension which will have the customer attributes plus the geography attributes. If you want to create one single dimension which will contain attributes of both the dimensions, then you have to recreate that dimension. You have to delete it and rebuild that dimension. But
what do I have to delete? The entire cube, or I have to delete what?
no, you just have to delete the dimension, rebuild the dimension, and then set up the relationship in the cube. Don't have to delete the entire cube. Just rebuild, just recreate the dimension, delete the dimension, recreate it, and just set up the relationship in the cube. But but let's say if you keep dim geography as a separate dimension, let's say you keep dim customer as a separate dimension, dim geography as a separate dimension, then you don't have to delete dim customer. You can keep dim customer as it is, you add dim geography to it, and then in the cube, in the dimension usage tab, there's a type of relationship called a reference relationship. So you can set up the reference relationship, and then also it will work. So it depends on your requirements. If you want to create a single dimension which will contain the attributes of both, then you have to recreate. But if you want to keep them as separate dimensions, then you don't need to recreate.
Okay, get it. Thank you.
Okay. So in this case, if I if I don't want the dim geography attributes to be included in this dimension, I'll just uncheck it. And then I click on next, and you can see here that I don't see the geography attributes here. The geography key is there, but the geography attributes are not there. But if I go to back and if I check this, then you'll see the geography attributes will come here. City, state, country, everything is here. So as of now, I'll keep them as separate. Okay. So I'll take the first name, last name, middle name, marital status, gender, email address, yearly income, total children, education, number of cars owned. Okay. So these are the attributes I've taken, and then I click on finish. So now you can see here that I've built this dim customer. Now adding and removing attributes is very simple. So all you have to do is, let's say I want to add an attribute here. So I'll just have to highlight it and just drag it here, and it's added. And if I want to remove any attribute, just right click on anything and just delete. So adding and removing is very simple, or you just have to drag and drop and then delete and then deploy. Okay, so I've built this customer dimension. Now I need to deploy and process this cube and this dimension. Okay, so before I explain how to deploy and process, there is a difference between deploy and process. So if you so deploy is when you deploy a solution, a multidimensional solution to a database, to a server, you are just building the structure of that multidimensional solution, cubes and dimensions. So deploying is not related to the data. The structure of your cubes and dimensions and your multidimensional solution is built when you deploy. And when you process, that is when it brings in data from your data source. So whatever data source you have defined, so that it will bring in the data from your data source at the time of processing. But if you see here, the deployment and processing settings are here. So if you right click on this and go to this is your project properties, and if you go to deployment tab, so if you can see here, so the processing option is set to default. So if you set this as default or full, then after deploying, it will start processing automatically. So you don't have to process separately. So processing is the second task of deployment, you can say. So if you set this as default or full, if you set this as do not process, then it will not process. Okay, by default it is on default. So in that case, it will, when you deploy, it will process as well. And this is your target server where your multidimensional solution will be deployed. So in my case, my target server, because I have installed multidimensional on an instance named dev01. So it will be installed, it will be deployed on this multidimensional instance, and whatever is the database name I want to give, I can give any name here. So I can give it SSAS training, whatever I want to give. Okay. So if I select this as default, then it will process as well. But if I select it as do not process, it will not process. Okay.
One question,
Yeah.
Indra here. The database, will it not be AdventureWorks DW 2012? Will it be?
Yeah.
Is it a new database we're creating?
No, the data source is AdventureWorks DW 2012 one.
Okay, but the target database here is a new name we're giving.
No, this is the target where the multidimensional database will be deployed. This is not the source. The source is here. Sorry, here. This is the source. The source is, if you go here, localhost dev01 AdventureWorks DW 2012. This is my source from where it will pick the data, and my target where it will be deployed. Target is where the multidimensional database and the cube will be deployed. That we will define here. This is dev01. And I can give it any name. Okay. So I'll go with the default because that is a default option. And I'll right click on this and click on deploy. Now you can see here that it is processing the DIM customer as well. So it has first it deployed, so deployment completed successfully. After deploying, it did the processing as well. Okay, so because why? Because it was set to default. Now if I set this as do not process, then it will only deploy. It will not process. You can see here that it is there's a green check, so it is deployed, no changes detected, but it hasn't processed it. Okay, so now the question that you were asking is what is the target and what is the source? So if you look at here,
There is a question here. Hello? When you say process, what does it do exactly?
process is
And in what circumstances you select the option do not process?
see, the thing is that when it processes, let's say if you have a data source, it brings in the data from your data source to your cubes and dimensions. When you deploy, only the structure is built. So ideally after deploying you will have to process, because unless you process you cannot use your cubes and dimensions for your reports, because there will be no data, because data is coming when you process. Deploy, if you only deploy, then you will see no data. It will be just a blank cube and dimension. And when you process, you bring in the data.
Okay. And when you said while deploying, the target database can be any name one can give. So what is the normal practice? For each project, one should give the separate database name for the deployment?
It all depends on the requirements, whatever has been defined by the technical architect of the project. So, if the technical architect has, whatever name they have decided for your multidimensional database, if they have, whatever name they have decided, you have to go with that name. Ideally, I mean, every company or every project has their own nomenclature and, and naming conventions. So based on that, they will decide on a name, and then you will use that name to deploy.
So first time it is created, and after that everybody keeps on creating new cubes in the same database?
No. Either, let's say you have created a database, okay? You have deployed a multidimensional database on your server, on your SSAS server. Now, next time there's any change to that database, so let's say a new dimension is added, or a new calculation is created on your cube. So obviously you won't create a separate database. You will override that database. So the database name will be same what was previously. You will just override that. So when you deploy, if it is already an existing database, it will override that database.
So how many cubes one can deploy under the same target database?
Under a database, there is no such limit. You can create 10 cubes, you can create one big cube, which is, there is no such limit as to how many cubes you can create. It again depends on the technical architect, that if they want to create 2 cubes or just 1 cube, or if they want to go with 5 different cubes, it all depends on the technical architect. But there is no such limit as to how many cubes you can create.
So does the architecture creates this target database beforehand and passes along this target database name to everybody to use it?
Yeah, they won't create it, but let's say obviously they decide on what will be the name. Otherwise, the developer will provide the name according to his or her wish.
Understand.
So I mean, they won't create it, but whenever a project is kicked off, there's a business requirement document. So there, they will, the architect will decide, okay, let's go with this name. Let's give the multidimensional database this name. Let's give the cube this name. So they will decide on a name and then provide that name to you. And then when the person who is developing the cube or the multidimensional solution, they will use that name. Otherwise, it will be like the decision of the developer. Whatever name they want to give to the database, or whatever name they want to give to the cube, they can give their own name. So it is naming is just like, you can say, the architect decides on the name, and then the developer uses it.
Okay, I understand that. So name is decided first, no database structure or anything created. So whenever the first time somebody employs cube, a database is created, and after that it gets overwritten. Right.
So every time, let's say you have a already existing cube and database in your production server. So obviously, let's say some change comes along. Let's say some new calculation has to be added in the cube, or some hierarchy needs to be created in the dimension. So obviously you won't create a new database. You will all just
Right.
override that existing database.
Okay, get it. Okay.
Okay. Also, like the thing is, like you cannot, if you create a new database, the reports, because the reports, when you create a report, be it an SSRS or any other reporting tool, so you specify the database name and the cube name as your connection. So if you create and deploy it with a different name, then obviously the report connection will also have to be changed, because the report connection will point to the old database name and the old cube name. And also, like the database space, so many redundant databases will be created. So obviously, once a database and a cube is deployed, every time any change comes, you will just overwrite it. So you can see here, like in this database engine, AdventureWorks DW 2012, this is the data source. Okay, this is the data source which I had specified here. And I have deployed my multidimensional solution, though in my multidimensional solution I have built only one dimension till now. But I have deployed it to this is my database engine. So when I connect to analysis services, this is my multidimensional engine. When I connect to this, you can see these are the databases. This is one which I had created earlier. So this is the one which got created just now when I deployed. So this is the one which just got created now, and you can see here that there are no cubes because we haven't created any cubes. Only one dimension is there, dim customer. And you can see here that I can browse the cube here. These are the different attributes. Let's say I go for first name, English education, marital status. Okay. So right now only one dimension we have built. So that is the one which is created right now. So now let's say in my dim customer, if you see now, I'll add on to this particular dimension. So if you see here in my dim customer, you can see that this is the customer key. So this is kind of, you can say, the primary key or the surrogate key which identifies each customer. So this is one customer, this is another customer, this is another customer. But to the end user, let's say you are an end user who will be consuming data from this multidimensional solution. So it won't make any sense to you. Will you be able to understand who this customer is or who this customer is? Because this does not make any sense to the end user. So what you need to do is you need to create a named column for this. So how we will create, because we have two separate columns, which is first name. You can see here first name is one column and last name is another column. So what I'll do is I'll create another calculation which is the concatenation of first name and last name. So what I'll do here is I'll go here, go to the data source view. Here I'll go to dim customer and here I will add a new named calculation. And here I will put full name. This is just a space. So you can see here that this sign that you see, this is a named calculation sign. So I've created one column called full name. Now if you right click on this and if you explore data, you can see here this is the full name of each customer. And here one important thing which you need to understand with multidimensional SSAS, for each these are called, each of these is called a dimension attribute. Okay, for each dimension attribute there are two very important properties called key column and name column. Key column is something which logically SSAS works on, and name column is something which is displayed to the end user. Okay, so if I go to the customer key and I just go to properties, you can see these two columns that I'm talking about, key column and name column. So you can see here that key column is customer key and name column is by default, it is the same as key column. So key column is something which logically SSAS will consider the key column logically when it does any calculation or anything. But name column is what is displayed to the end user. So I don't want to display the customer key to the end user. What I want to display is I want to display the full name to the end user instead of the customer key. So I have selected full name as my name column. And now if I process, you can see that it is saying that the server content appears to be out of, would you like to build and deploy the project first? So it will overwrite the existing one. It will not create a new database. So I'll click on this. So it is overwriting the existing one. Instead of process update, I'll select process full and run. So now if I go to my browser, and every time you process, you have to refresh and reconnect. You can see the dimension has been represented on server. So you have to refresh and reconnect. So now if you go to this customer key, you can see the full name of the customer instead of 1100 and 1101. So this is much more understandable to the end user. Okay, they will be able to understand who the customer is instead of displaying the customer key. So ideally you won't, you can rename this as customer instead of customer key. Okay. So like this, you can also build, different attributes. You can go to the browser and you can see here now you have the different customers list here. Okay. Now this was about the customer dimension. Now let's say I want to let's go into more development details about a dimension, because before you create the cube you need to develop your and build your dimensions properly first, because the dimensions are based on which your measure data will be displayed on the reports. So the next thing that we will be developing is the date dimension. The date dimension is one of the most common dimensions which you will find in almost every data warehouse, because every user wants to slice and dice the data with respect to dates. They want to see the data with respect to different months, different years, different quarters. So date dimension is the most one of the most common dimensions that we have. So I'll create the date dimension now. So I can select here dim date. And date key is my primary key or surrogate key. And here I can select the columns which I want in my date dimension. So English day, name of week, English month name, month number of year, calendar quarter, calendar year, fiscal quarter, fiscal year. Okay. And click on next. So these are my attributes which I have selected. So let me process the date dimension. Okay. So, before, when you, after I create the date dimension, I will also discuss one very common feature in case of dimensions, that is hierarchies. So, whenever you're using SSAs, most of the times as a developer, you would have to build hierarchies. Why we build hierarchies is firstly, number one reason is because the users, they want to view the data in a hierarchical fashion. Let's say you build a hierarchy where you have year at the top, and then you have quarter, and then you have months, and then you have dates. So users usually they want to view the data in that manner. They want to view the data at the year level. They might want to view the data at the quarter level. They might want to view the data at the month level, or they might want to view the data at individual day level. So it is the way users want to view the data. Also, in case of geography dimension, let's say you build an hierarchy where you have continent at the top, and then you have country, and then you have state, province, and then city, and then individual postal codes. So let's say you might want, you are an end user, you might want to view what was a sale for May 2015 in United States for a particular product. So then once you see that, you might want to see it, okay, for United States, the sale of this particular product for May 2015 was $5,000. So you might want to see it at the city level. So from the United States, you can create a hierarchy. Under United States, you will have the different state provinces. Then under the state provinces, you'll have the cities. So once you navigate to the city level, you will get to see what was the sale for each individual city. So that is why we build hierarchies, because end users, they want to navigate and they want to view the data in that manner, in a hierarchical fashion. Also, when you build hierarchies, SSAS knows that this is how users want to view the data. So SSAS aggregates data accordingly. So from the performance point of view also, if you build hierarchies, it is it is good from the performance point of view as well. So that is why we build hierarchies. So here what I'll do is I'll create a calendar hierarchy first. So I'll take the calendar here, and then I'll take the calendar quarter, and then the month, and then each individual day. Now I'll rename this as calendar hierarchy. Okay. Now if I go to the browser, and you can see here that for each individual attribute it's a rectangular shape, but for an hierarchy it's a triangular shape. So if I go to the calendar hierarchy, you can see I have the year at the topmost level, and then I have the quarter, and then I have the months, and then I have the dates. But you can very well understand from here that this is okay, but this is not understandable to the end user. Instead of this, wouldn't it be better if you would display something like, instead of 1, if you would display January 2005? That will be much better. Instead of 2, if you would display February 2005. So what I'll do is, I'll create named calculations for each of these columns. So, so I'll have to go to the data source view, and I'll create named calculations for each of them. So instead of typing, in order to save time, I already have an existing solution which I had created earlier. So I'll just pick the named calculations from there, so I don't have to type again. So here you can see that in this date dimension, I had already created some named calculations. So I'll just to save time, I'll just pick these calculations from here. So let me, so I'll explain it to you. So what I'll do is, for calendar year desk, let me take a notepad. So I'll also, so in case you require, I can ping it in the chat window as well. So I'll just, I'm concatenating CY with the calendar year. This is for the description at the quarter level. So it will be something like Q1 CY, and the calendar year, like if it is 2015, it will be Q1 CY 15. And this is for the month description. So this is English month, and which is January, and then this is calendar year. So January 2015, January 2014, like that. and this is for each individual date. This is for the fiscal year. And this is for the fiscal quarter. Fiscal year, and this is for fiscal quarter. Okay. So this was the project on which we were working. So here in when I come to dim date here, this is my dim date. So I'll add these named calculations here. So first thing I would add is calendar your desk. Okay, and then this one will be for the calendar quarter. Okay. So let's say let me browse the data and show to you how it will look like. So you can see for calendar year it will show like this, for calendar quarter it will show like this, which is much better. Like for previously it was just showing 1. So instead of 1 it will show Q1 CY05, which is much more understandable. Uh, Archishra, you want me to paste again? Which one do you want me to paste again? For which express? Because I have whole part. Okay. Oh, the whole thing. Okay, one second. Okay, so calendar quarter desk, and then for each month I'll concatenate it with the year. So new name calculation. Yes. So previously it was just showing 1 for January. So now it will show January 2005. This is the date description. So you can see that this is each individual date. Now what I'll do is I'll use these as my name columns. So instead of displaying the key column value, it will display this as the name column. So what I'll do is I'll go to calendar year and right click. Either I can open up the properties window by right clicking and click on properties, or by pressing F4. So F4 also brings in the properties window, and here I will go to my name column. This is for calendar year. This is for calendar year. So I'll take calendar year description as the name column. Now I go to calendar quarter, and here I will take the quarter description as the name column. And then I go to month, and I take the month description, and then I go to date, and I take the date description as the name column. Okay. So now if one more thing that I need to tell you, that here that you see this warning symbol, attribute relationships do not exist between one or more levels of this hierarchy. This may result in decreased query performance. This is a very important aspect of development of multidimensional dimensions, because if you do not set up your attribute relationships correctly, if you do not optimize your attribute relationships, the performance of your queries will not be good. The performance will be poor. So it will not perform in an optimized way. The performance that you expect out of analysis services, because people use analysis services to get good performance for complex calculations. So for that, setting up the attribute relationships properly is very important. If you don't set it up correctly, then your performance will not be good. It will not be optimized. So here, if you go to attribute relationships, the default relationship that you see is calendar year is related to date key, quarter is related to date key is your primary key or your surrogate key, and month is related to date key. Now this is not incorrect. This is fine. This is correct because each one year, quarter, month, everything is related to your primary key. So that is not an incorrect relationship, but it is not optimized. It is not an optimized relationship. That is why this warning is coming up. So it does not say that month will roll to the quarter and quarter will roll up to the year. So what you need to do is you need to optimize these relationships. So you need to go do this. So date will roll up to months, months will roll up to quarter, and quarter will roll up to year. So date will roll up to months, months will roll up to quarter, quarter will roll up to year. This is your optimized relationship. Now once you optimize your attribute relationships, you can see that this warning symbol is gone. Now,
Indra, what keys did you use to create the relationship?
sorry,
How did you create the relationship?
actually I dragged the, so in SSAS terminology, this is called a child and this is called a parent. So I dragged the child to the parent.
Okay.
So that is how I did. But if you were sometimes, initially, because I have done this many times, so it is easy for me. But if you get some issue, then what you do is just right click on this and go to new no, right click on this this relationship and go to edit attribute relationship. So here you will get the source attribute and here you go get the, so the child you select here and the parent you select here and then you click on OK. So then you'll get the relationship.
Okay, so right click on the link basically.
Right click on this. If you want to edit, then right click on this. If you want to create a new relationship like what I did from the earlier one, then just right click on this and click on new attribute relationship and then select this from here.
So it is an alternative to drag and drop basically.
Yeah, alternative to drag and drop.
Okay.
Okay, so so now my attribute relationships are optimized. So what I'll do is now I'll process this dimension. So now it's giving me an error. Now this is a very important error which you need to understand while you are developing multidimensional dimensions. So this is very important. You will come across this error a lot. So ideally when SSAS gives you an error like this, you will probably not get any useful information from these two. The important information that you require, that is here in this one. This is the important information that you require. You can highlight this and click on view details, so you'll get the error. Now this is very important for you to understand. Now it says a duplicate attribute key has been found when processing the calendar quarter column and value is 4. Now why this is coming? So this is very important to understand. Now when we specified the attribute relationship like this, so in SSAS terms this is called a child and this is called a parent. Okay, this is a child, this is a parent, this is a child, this is a parent. So when I say calendar quarter 4, previously I told you that SSAS works logically, it works on key column. Name column is only for display. So logically it will refer to the key column. So what is the key column for calendar quarter? If you right click and go to properties, the key column for calendar quarter is calendar quarter itself. So what values does calendar quarter have? It has 1, 2, 3, 4. It has 4 values, 1, 2, 3, 4, nothing else. So, and when you define the attribute relationship like this, it means this is the child, this is the parent. So you are specifying that for each child there is only one single parent. So it's a one-to-many relationship. So one parent can have multiple children, but one child will have only one parent. So when I say calendar quarter rolls to calendar year, so one value of calendar quarter will have one single parent. Now when for calendar quarter I have 4 values, 1, 2, 3, 4. So it was giving the duplicate attribute key for value 4. Why it was giving duplicate attribute key? Because for 4 exists in 2004, 4 exists in 2005, 4 exists in 2006. So 4, the calendar quarter 4 has multiple parents. It exists in 2005, 2006. For each year, the value of 4 exists, calendar quarter 4. So it has multiple parents. That is why it is giving me this error. So what I need to do is, in order to, this is very important, if you are working as a multidimensional SSAS developer, you will always have to do this. There's a very common thing which comes across, and you need to understand it, because you need to understand the data. If you don't understand the data, you won't understand how it works. So what you need to do is, in order to fix this issue, you need to go to calendar quarter, go to properties, and for key columns, you need to select a composite key column. So what the composite key column would be, it will be a combination of two columns. Right now it has only calendar quarter, which has 4 values, 1, 2, 3, 4. Now if I add calendar year to it, so the key column will be a combination of quarter and year. So 1 2006, 1 2007, 1 2004, 1 2005. So the quarters will be unique. So 1 2004 will have 2004 as its parent. 1 2005 will have 2005 as its parent. 1 2006 will have 2006 as its parent. So this issue will be resolved. Ideally, as a best practice, we keep the higher level at the top. So calendar year and then calendar quarter, and then I click on OK, and you can see here that key columns is a collection. So this is what we call as a composite key column. Okay, now I save it and then I process it. Now I'm getting again another duplicate attribute key error. Now here, you can see here that the issue with quarter is gone. Now the same issue is at the month level. For month, the value 1, it exists in every year, or it exists in multiple quarters. For 2004 also it exists. For quarter 1 2004 also it exists. For quarter 1 2005 also it exists. So it has multiple parents. So again, in order to fix it, we will have to create a composite key column. So for month number of year, what I'll do is I'll create a composite key column for this as well. So here also I will add calendar year. So a combination, calendar semester I can remove. So a combination of month and year that will uniquely identify each month. Okay, and I put calendar year at the top and then the month number of year. Click on OK. Then I process. So now you can see that the process succeeded. So at the date level, I don't have to do anything because each individual date is date key is unique. So I don't have to set a composite key column for that. So here, if you go here and you go to the C, this is my year level. Then I have the quarters, 4 quarters under C by 2005, and I have 3 months, January, February, March, and under January I have each date. Okay, So this is how you can build hierarchies and set up your attribute relationships for your dimensions. Okay. So we are already over with the time. So do you have any questions regarding what we have discussed till now? All right, then in that case, we will end today's session. And hello.
Hello, hi. I have two questions actually. So
Yeah.
is the general practice actually like once we set up the data source, then the data source view, then the dimensions. So or can we directly create the cubes and automatically while we set up the fact table and the dimension tables over there, it's the dimensions created by default?
You can create the dimensions before creating you can create the cube before creating the dimensions, but what will happen is, I will show you later that if you don't build the dimensions first, what will happen is it will only create the dimension skeleton with only the key column. So none of these attributes, the rest of the attributes other than the key columns or the hierarchies, they will not be created. Dimensions, yes, then you can build the dimensions later on as well, and then you can reprocess the cube. But generally, this is because anyways you have to develop your dimensions. So, and then the cubes use those dimensions. So generally, as a practice, we develop the dimensions first and then develop the cube.
Okay, either way we can do it, but this is the most preferred way, right?
Yeah,
I mean,
right,
and more flexible too. Okay.
right, right.
Okay, thank you.
All right, so we'll end today's session and we'll meet again tomorrow. So thanks a lot. And I'll upload the this video in OneDrive.